Okay, this is the third video that we'll do on the chapter differentiation, gradient of a curve at a given point. Example 1, given a curve that has equation y is equal to 2x squared plus 5x minus 3, and we need to find its gradient at the point x equal to minus 5. One way to do that is to draw the curve and then plot the tangent at the point x equal to minus 5 and find the gradient of the tangent by doing height over base. Or, more advanced method is to use differentiation. So if we differentiate this curve, we get 4x plus 5, and what that means, this is the gradient of the curve at any point. Therefore, if we want to find its gradient at the point x equal to minus 5, we need to substitute x equal to minus 5 into the equation dy dx, and we see that the answer is minus 15. So with this method, we don't even need to know how the curve looks like or spend any time by plotting the graph. Another type of question that may arise is to find the value of x when the gradient is equal to 4. So gradient is equal to 4 means that dy dx is equal to 4, but we see that dy dx has this equation, so 4x plus 5 is equal to 4, and we solve for x, and we see that x equal to minus 1 over 4. Example 2, a curve has equation y is equal to 4x cubed plus 5x plus 3, and we need to find the gradient of the curve at the point x equal to 4. So we repeat the same procedure. We differentiate this equation. We get that this 12x squared plus 5. At the point x equal to 4, we substitute that value in this equation, and we see that dy dx is equal to 197. Another point is to find the values of x when the gradient is equal to 53. So dy dx, which is 12x squared plus 5, that's equal to 53, and we solve for x. And because the equation is quadratic, we are expecting to have two solutions. X squared is equal to 4 means that x is plus minus the square root of 4, that we get two solutions, x equal to 2 and x equal to minus 2. A harder exercise is a curve with this equation, y is equal to 3x cubed minus 4x over x squared. And in order to find the gradient of the curve at the point x equal to 2, we need to differentiate. But this equation, first we need to rewrite it before we differentiate. So we divide each term by x squared. Now we simplify the x. Because the x appears on the denominator, we need to bring it on the numerator by changing the sign of the power. And now we're in the position to differentiate. So dy dx is equal to 3 plus 4x to the power of minus 2. And at the point x equal to 2, now means we need to substitute that value into this equation. What this value here means, we can bring it back to this form, which is this is a very important step to be able to move back and forth with the powers. Substitute the value of x equal to 2 in this equation, and we find that dy dx is equal to 4. We want to find the values of x when the gradient is equal to 4. That means that dy dx is equal to 4. dy dx has this form. Bring it the x squared, bring it on the denominator. So now try to solve for x. So we bring 3 on the other side by subtracting 3 on both sides. And square root of 4 plus minus, and we get two values, x equal to 2 and x equal to minus 2.